Good evening, or morning, I guess. This is Michael Locker. Um, I'm recording this video primarily to illustrate the calculator GUI that I made for Java OOP, Object-Oriented Programming 212, with my illustrious professor, Dr. Faye Garev. If you're watching this in YouTube land, don't think I'm crazy. It's a demonstration of an application I made in Java early in my coding, hopefully, career. Given that, without further ado, we'll go ahead and get started. Also, Dr. Garev, in case you're curious as to why I'm recording a screen recording, I think I may do some future videos for tutorials for myself, as well as possibly to help out with some stuff here at school. So, with no further ado, let's get started, although there will be a couple other points of explanation. So, first of all, period equals yield 0. That is correct. Alright, period 1 equals 0.1. While I'm looking at this, I want to note I have some system outs currently built into the GUI, just so I can see for diagnostic purposes, and because it helps illustrate even for this demonstration in times like this. For example, 1 equals 1, you can see that it is actually calculating, and when I hit clear, I can make sure it's actually doing what it's supposed to. I will take the system outs out before I turn it in, but in the meantime I thought that I would leave them in for the purposes of demonstration. We're going to get into some real arithmetic. 1 plus 1 equals 2. That's good. Alright, 1 period plus 2 equals 3. That's wonderful. This one might be a little interesting. Alright, 0. Nope, expected result. We're off to a good start. Alright, so far so good. I'm going to truncate these two test cases because they are essentially the same test. 10.5 minus 5 equals 5.5. That's the first one. And the second one, of course, challenges me to press equals again, which will yield 0.5. So mission success there. Minus 2 equals minus 2. And again, so you can see it's still working. Minus 2.2 plus 1 equals negative 1.2. And now we get into some weird ones. My last fix, I'm hoping, didn't in some way break this. I don't see quite how it would have, but, you know, sometimes you fix one bug and another one crops up. I've been experiencing that all night. In any case, alright, so far so good. 1 plus 1 equals, and of course if I press equals again, you'll get 3. And we're on to the second page. Now here we're going to go 5 times 5. Ooh, difficult arithmetic. It's going to give us 25. We'll clear that. 5 times 5 equals, I should have truncated those. That gives us 125, which again is the accurate result. Now here's where things get interesting. 5 times negative 5, except since it's the calculator GUI, as expected, it yields 0. It truncates the added operator off and calls it a day. Now, I would like to note, and I of course intend to include this in my paper documentation, but I wasn't quite sure if you wanted it in the GUI or not. But if we go ahead and take and put it in the line itself, my calculator is specially designed to follow both the standard operating procedure of a calculator, and from the line, if you choose to type in the equation, it will give us the PEMDAS induced result of negative 25. Now, of course, the calculator can do that too if we simply make it go backwards, ta-da, and we're on to the next run. Now this one's probably an even better example. Negative 5 times minus 5 gives us negative 10. That is the expected test case result. And again, if I take the time to actually use the line here, you'll see it gives us the PEMDAS result of positive 25. 2 divided by 2 is 1. 2 floating point, or I'm sorry, in this case a double, but it's still a floating point integer, if you will. Gives us 0.4 as expected. 2.5 divided by 5 equals... Oh, I put the math problem in wrong. That is not a mistake on my calculator's part. Hold on. 2.5 divided by 0.5 is 5. That is exactly what it should yield. 1 divided by 0, it gives error. Now, I really wanted to replace this with undefined because it would be more accurate, but my instructions say to make it equal 0. So it equals 0. 8 divided by 2 equals 4 equals 2 equals 1 equals 0.5. And moving right along here, 1 divided by 3 gives us 4 decimals of accuracy. 2 divided by 3 gives us, again, 4 decimals of accuracy. 1 plus 1 plus 1 equals 3. And finally, 5 plus 6 divided by 2 equals 5.5. And one last period of showing off. If I put it in manually, it will give me the PEMDAS result. I'm very proud of that. That took some engineering on my part, I think. Given that, I have successfully created Calculator GUI app. And I guess you can't see it right now, and perhaps I should reformat this in some way, but it is actually labeled. But it looks so cute like this. I don't know why Windows did this. Anyways, thank you for watching, and have a wonderful day.